Live now.
Okay. Yeah.
Hello and welcome to Digital Futures tutorial session. As we begin April month, we have a very interesting session with Dhruval Shah today on urban cartography using open source data. Before we begin today's session, I would also like to inform our audience about our next and upcoming session in the month of April. Next. Next week, we have a very interesting session, again, based on our insider series with starting with ICD Stuttgart, MIT Media Lab, and now on 9th of April at 10 a.m. EST, 4 p.m. CET. At the same time on Saturday, we also have Inside ETH Zurich. Next, please. All our sessions, including today's tutorial session and many other language session in Spanish, Farsi, Portuguese, Arabic, English, all of our material is available online for you to check on our YouTube channel, Digital Futures World. The link is available as seen on the screen. Also, we would like to invite any of our audience who are interested. Just next, yeah. Yeah, any of our audience who are interested in maybe conducting a summer workshop or hosting any of the language sessions, any new language sessions also are invited. We are on a lookout. Please write to us at info@digitalfutures.world or join our Discord channel. Our Discord community is very active. Now, without further ado and without keeping Dhruval waiting for long, I would like to just give a very brief introduction. Dhruval is currently working at Zaha Hadid Architect in London, in their London office as an architectural assistant. He's a graduate with MArch in urban design from Bartlett School of Architecture, London, and a bachelor's degree from University of Mumbai in India. He has been interested in the subjects of mathematics, technology, arts, storytelling since childhood. He finds his interest in integrating within their complexity while exploring architectural design using computational tool and processes of generative design. His explorations go beyond beyond architecture and extend to cartography, graphic design, portrait photography, and many more things. We're delighted to have you, Dhruval. And I would not take much of your time, and let's begin with the session and know more about your work. Welcome. Yeah.
Thank you so much for that sweet introduction, and I'm absolutely excited to be here and absolutely honored to be a part of Digital Futures from now on. Yep, so I guess let's begin with this session, and I'll start sharing my screen. Can you use my screen?
Yeah, we can see your screen.
Yeah, perfect. Okay, so hello everyone, and welcome to the session called Urban Cartography with Open Source Data. So how this session will move ahead is we'll have like short segments, things where I've like segmented based on certain information bases, and it would always, of course, be a mainly GIS tutorial sort of, but I have still made like shorter segments for where I will explain certain terminologies and concepts of how GIS works, or what is GIS, and how urban cartography can be explored. I'll be jumping between the presentation and the software in between so that it's easier to understand and it's not all imaginary for the participants to say what I'm saying, because GIS has terms and elements which are not really very popular or to say very much in everyday use as such, but they are pretty much in the fraternity common terminology. So it wouldn't be much difficult, I believe. Yeah, beginning with the introduction, I think Bhavin has given a great introduction to myself, and I've been working with Adi as an architectural assistant since some time now. And this workshop is mainly about data visualization in a way. It's more precisely called as geospatial data visualization. And why urban cartography? Because we would be talking more about cities than overall data viz. And about the download links, I think the participants must have got the download link, and I think it is also put into the description. And it contains two things. One is the link to, I think, three things. That one is the link to download the software, which is called QGIS. It's an open source free software, so anybody can download and use that. And then it has certain data sets with it, because data sets sometimes take time to search and download and gather on. So I've included the data sets in the link, so it's easier and faster for participants to use and explore them already. And then there's another Word document which contains additional links for downloads and for more information about these elements that I'll be talking in the workshop. So later on, whenever somebody feels they want to explore more, they can probably take that as a starting point and, of course, go much more beyond than that. So beginning with introduction to geospatial data viz. So as the name suggests, it has 4 elements: geography, spatial, and data, and visualization. So all of them combined basically comes down to putting it all onto a map, sort of, to say in a layman language in a way. So what is data viz or data visualization? Basically, it's just representation of data in a graphical form, which I'm sure everybody has been doing in some form or other since our childhood and in everyday life as well. So every single graph that we make with certain kind of data or information is in a way a data viz. And so this is one of this is one of my work where I just took I just had like 5 senses and certain words which were classified according to those senses, and then had sub classifications for other smaller terms. And I just put it into something popularly known as a dendogram in a way. So just took a just had my take on the dendogram and just had all the words sorted from in a way usual positive to negative to positive meanings, and then sorted them with the kind of senses that you can associate them with, and some other sub classifications. And the colors also indicate the negative to positive impact of those words in just general forms. So that's like a very simple example of beginning to look beyond usual graphical methods or usual tabular methods of classifying data. And this could be a much more quicker way to understand certain data types. So geospatial data viz, as I said, it requires geography, it requires spatial demarcations, and it requires data, and it's a visualization form. So obviously, it's just representation of data in a georeference graphical form. Now, this is just a usual screenshot I've taken from Google News, which anybody can search for coronavirus numbers and just get this same sort of a data viz graphic, wherein it just shows what amount of coronavirus cases and deaths have been recorded in various locations in India and inside the states as well. So it just becomes a very quicker way of understanding what has the virus has impacted where, and where do we need to allocate the resources accordingly. So question is, why do we need urban cartography if we can, we already have certain usual graphical forms of representing data, and the life has been pretty good so far, right? I mean, industries have been moving forward smooth enough, but why is there a need for this? So let's go back to a short moment in history where this was the time when London was suffering through a cholera outbreak, which was huge, and nobody had any idea what was the cause for it or how to stop it because they didn't even know where it began. But somebody called Sir John Snow, not the one from Game of Thrones, of course, but yeah, he sort of started to plot the cholera cases based on their residential locations, and then sort of had this map that you can see on the screen. So this gave certain information that it was coming in a way from a concentrated area, wherein a certain water pump was infected, and that was the main cause of cholera outbreak at death. So if you would fix that, probably it would help in reducing the outbreak in itself. But obviously, not many people believed it in the first place. But eventually, people accepted it, and it did help to get it in control. So, yeah, well, that was in a way the first recorded instance of urban cartography or like urban data was in a way. So well, geospatial data was in general just makes it more natural and intuitive for human minds to comprehend and identify trends, patterns, or outline information by means of visual contexts. So uh, before we actually begin to start visualizing data, we also need the help of mapping and cartography. Now it has certain science to it. So uh, Leonardo da Vinci was is believed to be somebody who had the first records of scientifically mapping a urban area in a way. I mean, of course, there were maps before him as well, but they were sort of more towards the artistic outreach of it. And he is believed to have put some science and technicalities into mapping, and that's like the realm of cartography. So, the first thing to cartography is understanding how do you actually map a globe onto a flat 2D piece of paper or even a 2D piece of screen, right? So you take a globe and you have to cut it into a 2D piece. So basically what we are going to we do is we project the globular lines onto either a rectangular line or at least some shape that we can ultimately unroll into a 2D shape, at least on a flat surface, right? So as you can see in the graphic, it's like certain projections that go on to a 2D form. But in doing so, it modifies certain amount of cartographic data and geographic data, of course, because it is going to pull certain areas more from the globular lines to flat lines. And as you can see in this graphic, uh, the more you go towards the poles, the more it gets stretched towards respective poles, right? So the graphic on the right shows those red circles, which indicates how much more stretching is happening in those areas. So this is a GIF where you can see the actual sizes of the country maps to the sizes that we see on our 2D map. So because of the projections that we get from a 3D to a 2D, we can see the amount of stretching that is happening with each map. And why this is important is because there are multiple ways of projecting the maps on a flat piece. So the software allows you to choose any and all sorts of methods that you would like to do. But we'll see what we want to do and what's the easiest method to do it. So let's move on to the software. I believe some of these basics would help in clearing on how to begin with the software in the first place. And this whole method of data is put into a software which is generally called a geographic information system, or in short GIS. And it just basically is a system that creates, manages, analyzes, and maps all types of data. So this provides like a good foundation for mapping and analyzing for almost every industry. So the software that we're going to use is called QGIS, and it's a open source developed software. So that's a good thing about it, that anybody can use and access and use it for any kind of purpose that you would like. So when you open the software, this is like the introduction screen that you would get. And all we have to do is just go into the top left corner and just say new project, and it just creates a blank screen. So in terms of the layout, again, it's a very simple, clean interface. The center is the canvas where we would do all our magic tricks for photography. And above that is all the ribbons for all the kinds of tools. On the left side, we can see there are more tools, or more like organizational tools. So these are the places that you can browse your files or for systems. These are some of extra tools that you can use. And you can see here is the layers. So basically we'll have layers at the bottom when we add them. So this is like the layers panel. Clean, nice, and pretty much organized. Nothing sort of difficult about the interface. So moving back to the presentation, next we can see is what are the data sets. Now we have the software, we have an idea on what we want to do, but the initial thing is the information that we want to put in, or what kind of data sets, to say in the terminology, are we going to put in. So beginning with data sets and data sources. So how do you get those data sets really? What are the types of data sets? Because this is the age of infinite information and data, right? So we have to classify it somewhere, break it down somewhere, and it has to be available somewhere. Most of it would always be available. Some of it may not be, and we might have extracted sometimes. But to begin with, in basic terms, we'll see what are the usual data sets that we can use as a beginner. So the first one is, of course, a base map, because without a map, nothing would make sense, and there would nothing be to reference towards geography or a spatial demarcation. So base map would just be our guide, sort of. So one can get a base map from either of these websites, and there are many more. Of course, there's Google Maps as well. You can take a screenshot, you can export it in various forms. Google has multiple options for that as well. But these two are like open source base map sources. So you could just access it on the website in any form. If you just go to OpenStreetMap.org, you could just zoom into anything. And again, it's like any other open source software or element. It's made by the community. It's made by a combination of multiple people walking around the world. Basically, anybody can add to this. So yeah, you can see there are multiple layers available that you can see the maps in form. So this is like a transport map where you can see all the public transport availabilities, the railway lines, the railway stops, everything. You can see cycle maps, where are the cycle lanes available, what kinds of cycle lanes are those, and etc. So you can have a look at this, and probably even search for many more other feed tools available like this, or websites available like this. So in QGIS, how do we really get this open source street map? So the easiest way to do that is simply going to plugins, and then going to manage and install plugins. Yeah. So you would get a screen like this where there's a list of tons of plugins available. So you can just search for OSM, which stands for OpenStreetMaps, and go down to Quick OSM. So there's a check mark here, which means that's already installed in my PC. So I don't need to install it. Otherwise, you can just click on it, and then you can just say install plugin, which will be here, and then just close this. And I would go on this left top panel over here, and then I would go to XYZ tiles, and then you can see there's OpenStreetMap, and I just double click on this. So now the whole OpenStreetMaps website is open on your QGIS interface, and you could basically just zoom in and it would increase the amount of detail that you have on your map. It's taking a bit of time on my system, but yeah, I think it's, yeah, you can see clearly as more and more you zoom into a place, just like Google Maps or any other mapping apps, it just goes on increasing the amount of data that you can see on the screen. So we'll keep this as the base map on our canvas for now. And then we'll come back. So now the important thing to note here is that this map has opened flat. By flat, I mean the usual way we see maps always, right? So when I talked about projections, let's see how it looks when you really have like different kinds of projections. So to do that, I'll go to top left corner and say project. I'll go to properties, and we will have a screen like this where there are various other subcategories. I'll just go to CRS, which stands for Coordinate Reference System, which is a technical term for projection in a way. So if I increase this, you can see there's a huge list of kinds of projections that we use, because and the reason why we have so many different kinds of projections is different people trying to explore and simplify cartography and minimize the amount of stretching and pull that we have in the maps with various techniques. Also, every country wants to have their map as the flat most possible map. So it's okay for each respective country to see other country maps being stretched on their map, right? Because we want to see our map in the most accurate possible way. So every country would have their own sort of projection way as well. So or so to say, their own coordinate reference system. So that's why there's like a huge list of different projection coordinate systems. But the most commonly used would be WGS 84 or WGS 84 pseudo Mercator. Now, Mercator is the name of the person who sort of discovered or invented this projection style. And we would mostly use pseudo Mercator because that's the flat-most way of putting the map, like or the most two-dimensional way of putting the map. So if let's say we take a random sort of projection and apply that to our project, let's see what happens to the map on the screen. It's processing, it's in a while. Yeah, as you can see, I don't know what projection I used, but pointers, whatever projection it was, it has completely skewed the map, and it has changed the map in more like a circular manner. So I think it has like the focus on the polar areas of the planet, and so according to that, everything else is skewed. But yeah, I mean, you can try out various different CRS style and choose the best that you think gives you the best functionality or best aesthetics. But for now, we will go ahead with the WGS84 pseudo marketer. So it also has like a EPSG number. So basically, if you want to check what CRS system is your file using, just go to the bottom right corner of your screen, and there would be something called EPSG written over there. If you just hover your cursor, it would give you all the information. So right now it says WGS84 pseudo marketer, EPGS 3857. So I mean, that's the one that we want to use right now. Right. So yeah, that's like the base map. And going back to the presentation, what's the next thing that we want to look at?
Dhruval, there is a question in the chat. I think they want to ask is that I've been using OpenStreetMap for a long time, but with OSM, we cannot get accurate data for Indian maps. So what is the alternative for that? Do you want to take it now or later? Yeah.
I guess I'll come on that later at the end. We have our own ISRO's various systems and websites that we can use. But yeah, I'll come on to the additional sources that we can use to get different kinds of information at the end altogether. Okay. I'll open that Word document and yeah, I'll go through all of them. Yeah, cool. So yeah, moving back. So that's base map for us. Next would be a shapefile. So now a map so far is graphic for us, or more so, if I can say, just an image that we are looking at, more like a interactive image that just increases and decreases the amount of detail on our screen. But to really do our own sort of a drawing or a diagram, we would need that in a more accessible format where we don't have to Photoshop the map, but we can actually interact with the elements of a map and use it. So the most obvious way to do that would be a vector format, wherein we have all the lines. So vector format is something that we use in AutoCAD or in Illustrator even, so where we can directly interact with the lines and curves of the drawing. So that's the same idea behind this kind of data set, but it is called shapefile in this context of geospatial database. So it comes in like various different file formats, which is like SHP, HSX, PWG, etc. But essentially, all of them are the same kind of data sets, and they all of them can be used with QGIS. So just to show a quick example of that, I'll go back to QGIS. I'll go to layer on the top ribbon. I'll say add layer. I'll say add vector layer, and I locate my shapefile. So in the data file that is there on the link I've shared, you can just go to any sort of thing. I'll go to, let's say, India admin, and I'll select any of this, just SHX file. So let's add this one. Let's see what it gives us. Let's close. So as we can see, it gives us all the administrative boundaries of the different states. Now, to really interact with this, so how do we do anything with this, right? So to go on the top ribbon again, and there is a tool called Identify Features, which is the symbol with an I, information symbol. So just take that and just click anywhere. So if it has interactive element, or if I can say like a shape file element, it will get highlighted, and on the right it will show all the details that are available about that in the file or in the data set. So if any of this detail is absent in the file, then it won't show it. So we need to make sure that whatever data set that we are using comes from a good source, which is at least believable, if not authentic, because sometimes open source sources can be not authentic, but it's at least believable. We double check that the information that they are providing is correct enough, right? So I clicked on any different state and it shows what is the name, what is the type. So it says state and it has other various categories. So simply what I can do is I can just right click on this. I can go to properties. Now I don't like the way it is put up on my map right now. So I'll just go and change that. So I'll go to properties, I'll go to symbology, and instead of simple fill, I will go to here and I'll just say, maybe I'll just keep it simple fill, but I'll remove the fill color. So I'll say transparent fill. I'll say fill style is okay. The stroke is okay. I'll say apply. So it just shows me the boundaries right now. I'll just change the stroke style. Probably let's say dash and dot and say apply. Maybe I can increase the stroke width. So yep. So yeah, you can play around with the aesthetics of this file. So because this is a vector file, a shape file, you can do things with its stroke and fill, just like you would do it with on AutoCAD or Illustrator. So yeah, that's pretty much for this kind of shape file. There can be various different ways of doing this, or various different kinds of shape files for this. But we'll come to that probably, or actually I can show another one. I'll go to layer, I'll say add layer, I'll say add vector layer again, and then locate another file. So let me go to, let's say we say Indian Rails. So I'll just take the SHX file. You could take an SHP file as well. Say just let everything be default. I'll say add. Let's close, and it has added the Indian Railway. So we can't really see the lines right now. So I'll turn off street maps layer. I'll turn off the administrator layer for now. And you can see this shows all the railway lines for India. So this could be an old data set as well. So right now, please don't jump on me saying that, oh, that's a missing link on here. But yeah, point is, if you get like a updated data set, it should be pretty much like how this is working. And you could literally just change anything from this. So I don't really like the white layout. So what I'll do is I'll go to project again, I'll go to properties, we'll go to general, and I'll go to background color. I'll simply take black and say apply. Okay, cool. This looks much better for me. And you could really, again, just right click on the layer, go to properties, and once the tab, yeah. And you could change the color. That you can again change the kind of stroke that you want to see. So I'll go to simple line again. Here I think simple line makes more sense to keep it like that. You can use different kind of dotted line, or you can increase the stroke, or if you like, let's show it more like a railway line maybe. So I'll give it an offset. So I've given a 0.4 offset right now. Oh, perfect. Okay. So let's see it. Simple line. That's not custom. You can change your custom dot pattern as well, or you can trim the line somewhere if you like. You can use various presets which are already given over here. So you could really take, let's say, this one, which looks more like a railway line, and say, okay, I could change the color to red maybe. Yeah, fine. This looks more like a railway line. So just for symbology of it, if I just zoom it out, yeah, you can see that's like the complete uh, railway network of India. But yeah, it's too wide. So we'll reduce that. Yeah, much better already. So yeah, pretty much there. And again, if you just go to this identify features and just click on any of these lines, you can see it has different, probably this could be like a station to station vector curve as well. So it just shows all the details that the file carries for that particular curve. So it says railroad, it says operational, at the country is India, of course. It gives you the length, it gives you the latitude, longitude coordinates. It says X and Y of that, and many other different categories of information. So this is like the shape files, right? So can play around with a lot of things in this, with the kind of aesthetics you would like to have it on your visualization. And the next one would be, yeah. So the image on the left here is it's called the river veins network, basically. So it's like if you drop water anywhere on the land, what is the valley curve that it would follow, right? So these are all the water vein networks. So again, you can find this information very easily over the internet. You just search for it, and there might be multiple sources to download it as a shape file and use it. So next would be raster file. So I'm sure everyone must have seen the image on the left, which is a elevation map of the Indian subcontinent. I think this got pretty popular, and it's done by an artist with the organization called Etsy.com. So yeah, that shows all the mountainous regions and the elevations of each area in India. And on the right is what Mumbai elevation is. So let's check it out on how do you do it with QGIS. So I think let's keep the rail line as the base map for now. Let's not go back to OpenStreetMaps. So let's go to, again, layer, add layer, and go to add raster layer. In that, we can again go to data files, and there's something with this kind of a weird name. So these are downloaded from Indian Space Research Organization, which in short is called ISRO. It's downloaded from the ISRO's official website. So this is an authentic source for this kind of data. So I'll just open that folder, and you can see there are various different formats for the files, and it also has a shape file as well. But right now what we are interested in is a raster file. So what is a raster file is basically, as the name says, it's an image file. It's a pixel file, right? So basically it contains information in format of an image, and it's not a vector image in a way, but ISRO provides vector information as well along with the raster image for the same thing. But right now we'll use the raster image. So I choose the .tif file, which is a image file. I'll say open, and again I'll just say add, and then I'll say close, and we can see the file has automatically placed itself in the correct coordinate, because the file is already made with all the correct latitude, longitude, and coordinates and everything. So if your CRS, the coordinate reference system in the file, in the QGIS file, is correctly chosen, every data set that you add onto the file should fall in exactly the correct location. But let's say if your CRS is wrong, so just for the sake to show you, I'll set the CRS to something random for this particular file. So as we can see, it just disappeared from this location. And now I don't know where is it. So I'll go to layer, I'll say right click and I'll say zoom to layer. So it basically says it is there on the file, but we don't know where it is because the coordinate systems aren't matching. So to check that again, I'll right click, I'll go to layer CRS, and you can see this 1984 is the coordinate system which this particular layer is using. But as we know that our file is using the pseudo Mockito or WGS84 CRS, so that needs to match with the layer as well. So I'll just go to again layer CRS and I'll go to EPSG 3857 because that's the one that our file is using, and you can check that from the bottom right of the file over here. So I'll just go there and I'll just select this, and again we can't find it, so we'll just right click and say zoom to layer, and it zooms to the layer. Okay, again it doesn't seem to fall in the correct place, so go to properties, right click, layer CRS. I'll say just set project CRS from the layer, or yeah, and then let's see if it sits in the correct place. No, it's lost this layer, so let's just remove the layer if it gives you a lot of trouble. So I'll just add a new layer. Again, I'll choose the TIFF file and say add and close. And zoom to layer. Yeah. Again, now it's in the correct location on our map. So now, as we can see, this map is not really conveying any recognizable information, to so to say. So what we'll do is we'll go to right click on the layer, again go to properties, and in properties there are again various tabs. Information, which gives you general information about the file, all the digital signatures and kinds of information that it holds, and the file locations, etc. This says source, so basically source is the CRS that the file is using, etc. It says symbology, which is about the visualization or the aesthetics of this or the graphic of this particular layer. And then there is more different things that we don't want to look at right now. For now, what's important for us is the symbology, because we want to have it in a form which we can recognize and understand, right? So what we'll do is we go to render type on that's the first option, and it says single band gray. So we'll click on that, and I'll go to hill shade, and I'll say apply. So as we can see, that converts the file into a more recognizable form, which is kind of a mountainous sort of a graphic. So this is like the raw form of the ground, right? So it shows like absolute detail of each location in the city of Mumbai. Oh, so by the way, I just located this raster file for the city of Mumbai. And to confirm that, what we can do is we can just open our OpenStreetMaps again, and we see this overlaps on the city of Mumbai, right? So this is Mumbai over here, and our file overlaps with that, right? So yeah, that one small part is missing, which we will have it from the other file. So yeah, this is like the elevation map of this particular region. So same way one can download elevation maps for all the regions and then combine that and then form something artistic, which we saw on in my presentation. And let's say I'll just go to properties again, and we want to change the colors, the blending mode, brightness, etc. So one can do that with all the options available here. Just usual options. So for now, I'll keep it usual. And what I'm interested in right now is the contours. So basically, if you are looking at an elevation map, that's basically contours in a way, right? So as architects or as urban planners or urban designers or even as geographic surveyors, what we are going to be interested in, how much is the ground elevation, and the best and the most common way to understand that in a visual form is a contour drawing, right? That's how we usually discuss about that. So there's a direct option in this where you can just select contours and then say apply. So as you can see, the file is disappeared, and instead of that, there are some contours. But right now it looks very sparse, right? So that's because the contour interval is high, right? So it says 100 meters of interval. I'm not sure if that's meter or something, but point is that the contour interval is too far away. Most probably it is meters only, but we want a little more detailed information about the contour. So what we'll do is we can just reduce this interval to a different number, and the smaller we go, the more information we are going to have about the contours. So basically, it's going to show you more and more detail of the contour. If I say, okay, I'll turn off the OpenStreetMaps. Okay, let's change the color. Let's go to properties. Let's see. It says contour symbol. So of course, that's gonna be a simple line by default. So what you can do is you can go on, again, it's the same method as we did with the shapefile, exactly the same options. So I'll just probably select a red. Stroke width is fine for me. I'll say dash line or something. No, I'll say okay, I'll say apply. And that is, again, it's too thick right now. So let's reduce a little. So okay, and then if you start zooming in, you can see more contour details of each of the areas, right? So this is coming directly from the satellite image from ISRO's systems. So you can very much rely on this, I believe. And you could even like export this in a DWG format that you can use it in a AutoCAD file or directly into a Illustrator file as well. So all you have to do is just go to project. You can go to project, you can go to export, you can go to export project to DXF, right? So DXF is a format that AutoCAD will read. So just export this and it will come into a vector file format that AutoCAD will read. So for now, I'm not gonna export that because we are interested in something more right now here. And we'll go back to the presentation for other data sets. And yeah, that's pretty much what we saw on QGIS. And moving ahead, the next one is a delimited text file. So this is one of the most commonly used dataset file. Why most commonly used? Because it's a file format that doesn't really depend on the kind of data, right? So for example, if you wanted to see administrative boundaries, you would have to have a vector file, right? Otherwise, you can't really have the curves and things like that, right? So a CSV is a delimited text file is basically a huge sort of you can relate it as an Excel file sort of, which has various rows and columns with tons of data in it. basically. So if you see on the left, so you can see all the headings on the top left. It says stop ID, stop code. So basically delimited text files, how they are formed is they have all the headings, all the information below the headings, and you can open it in different forms and different ways with different software. So the software that is used for this right now is called Sublime Text, which is a very commonly used software for looking at a delimited text file. So yeah, let me get that on the screen. Yeah. So this is how Sublime Text looks like. So basically, it's a very small little application just to open this kind of file sets. But you could really open this as an Excel file as well. I mean, .csv is Excel, MS Excel or Microsoft Excel accessible format. So if you just double click on this and say open with Excel, it will open as an Excel file, which looks something like this. So it's the same headings as we had in the Sublime Text, but it's just in the tabular form we can see usually with Excel. So the first line will always be all the headings, and then below that we'll have all the information dependent on the category. So yeah, that's like a delimited text file. Now, these text files can contain any sort of data, right? Because it's a text file. It could be any kind of data as well. So it's used in every kind of industry that you can imagine, right? I mean, even in economics, or if you could say rocket science or everything, basically, because there's going to be multiple headings that you can put this under. So the most common file format for this kind of data set is called CSV, which stands for comma separated value. So as in the image, you can see after every heading, there is a comma, right? So that separates the value, right? So every time a software has to read this kind of a data set, it knows that wherever there's a comma, it has to put the next value in the next under the next heading, or the next value is different from the one before the comma, right? So that's why it's called a comma separated value. Nowadays it has evolved, and you could really have any kind of symbol instead of a comma. It would still be called a CSV file, but you could really have just any kind of symbol for separation of values. And it can come in other more coded formats like JSON or GeoJSON or XLS. XLS is, of course, the Microsoft Excel format, as we usually know. And there could be more. So if somebody knows coding or Python, one can extract a CSV from other kinds of data files. So let's have a look at our CSV file in this. So let's again go to layer. Let's say add layer, and I'll go to add delimited text layer. And again, it asks me the source. So I'll go to the main folder of data files. And then we have a Mumbai house prices.csv. So this data set has been downloaded from a website, which is a online real estate website, where one can just post about their houses, and people can just rent or buy and make deals from the website directly. So you could so these kind of data sets are usually public data sets, because you can view them, of course, on the website, right? So it's a public information, right? So it's publicly accessible, right? But there's a little more procedure that you would have to do to download it as a .csv. Now, that could be a completely different tutorial in itself. But for now, let's understand that these kind of data sets are freely available, and that every company or every privately owned or government institution which publishes public data will always have ways and procedures to give you these kind of file formats for the data sets, right? So for now, let's just open this. And as we can see, there are more options below this. Now in this one, we should check the options before we add the file. So it says file format, which is CSV, and that's correct. It says number of header lines to discard. So basically, as we saw in the Excel, that the first line is the heading. So we don't want the software to look that as a value line, right? So that's why we'll say 0, because that's the first line that it should ignore. And then after that, let's keep all of this usual. And then there is something called point coordinates, right? Now this file has geographic information. How do I know? Is because when I open this file, there are headings for latitude and longitude as well, right? So what we're going to do is in the X field, I'll go and select latitude. In the Y, I'll go and select longitude. And then you see the add button activates. Otherwise, it wouldn't activate because the software wouldn't know where to put the points to, right? So we'll just say add and we'll say close. Let's look at where are the points. I'll right click, I'll go to zoom to layer. And okay, there seems the file has some glitch or some misinformation, so to say, so that some of the points have fallen somewhere else. But most of them seems to have come in the almost the correct area. So let me just turn on our base map. Okay, now I see we have made a mistake. So I'll go back to properties again for the layer. Hasn't fallen into place. So what we'll do is go to okay. So what we did is we gave wrong X and Y, or like the sorry. I'll go to add layer. I'll go to Delimited. So latitude and longitude was the error, right? So instead of giving longitude in X and latitude in Y, I gave it the other way. So that put it in a wrong place. Now I believe it should come in the correct place. So yeah, we can see it has fallen correctly. Some points have gone haywire, but that's the error in the data file itself. So probably that if you can find the wrong points and go in this huge set of, I guess, what, some 50,000 entries, find that and fix that, yeah, you can have those points in the correct location as well. But we can see all of the points are now falling in the correct location. So yeah, that's like, so again, this is an indicative data set, right? Why I'm saying indicative is because it contains information that is coming from a privately owned website about real estate, right? So this is not an information which the government holds in its records for each of the sale of house or rent of the house contracts, but this is coming from what people have posted for their expectations of their property on the website, right? So it's still a very good source and an authentic source to understand the patterns and the what do you say, how are we looking at the inflation in the real estate, right? So could really be used like that. Now what we can really do with this is we can just go to properties and we go to symbology. We can go to graduated, and before that, let's see what all fields do we have, right? So if you click on fields, it shows there are many different information headers that this file contains, which is really amazing because it has a lot of information about each property. It begins with area, bathroom number, bedroom number, city, floor count, furnishing, latitude, longitude of course. It has a price tag as well. Uh, it has user types, etc., etc. So what I'm gonna do is I'm gonna, let's say I want to categorize all this information based on the area, right? So what I'll do is I'll go to symbology. I'll say on the top, I'll say graduated, and in the value, I select area. You could do it for any other header as well if it allows. If the heading has correct information, it will allow you to choose it from here. I'll say area, and for symbol, I'll keep it a single point right now. There's a color ramp, but we'll come to that later. And I'll just say classify here. So what it will do is it will take all the entries in consideration and create classification based on so over here it says classes 5, so it has created 5 regular interval classes from the minimum to the maximum number that is available for area in amongst all the entries. So we can see it has created 5 different color shades for based on the color ramp that we provided. Let's see how it looks for now. So I'll just say apply, and you can see it changed all the dots as per these classifications, and the colors are according to this, right? So let's make it look a little more beautiful, or a little more intuitive rather, I would say. So I'll just turn off the base map and I'll go here again. Let's say instead of a point, I'll remove the stroke color, and we just have the fill color. So right now the fill color here doesn't matter because it is gonna get override by the graduated color ramp that we give, right? So all I'm interested here right now is just the point size. So I'll decrease the point size. Let's say okay, and let's choose different. Let's say I'll say this color ramp. I'll say apply, and you can see all the uh, visual of what area types are available. So basically, if you go in the layers as well, you can see the color ramp of the dots. So the areas are indicated alongside the colors. So what regions in the city of Mumbai has more availability of what amount of area properties, right? So this is like a very basic, quick uh, exercise, or like a quick objective that you can fulfill using different headers in the data set. So yeah, I mean, this could be used for various purposes if one can imagine further questions on this. So yeah, that's like a CSV file or a delimited text file, right? So these are some of the main data sources that are most useful or more popularly used. There could be more beyond this, but that would be a very rare case that you would come across a different kind of data set. So for now, I'll stick to these amounts of data sets for now. And I'm sure that almost 80 to 90% of times you would come across only these kind of data sets. There'd be very less chances that you would have a different kind of data set and you'll have to follow a different procedure. Even if you have a different kind of a format file, for say, like if you go to QGIS again and go to layer, say add layer, you can see there are many more different kinds of layer possibilities that it allows, right? So which means there are more kinds of data sets probably available, right? But ultimately, everything is going to come down to the same kind of operating procedure, if I can put it like that. So it just, if you add a layer, the amount of data sets it will have, you just go here, you just say right click, you just say properties, and it will open all the similar kind of headers under it. And then you can check out if you go to let's say like how this has fields. If you go to fields, it will show you what all kind of data type or like data headings it contains. Right, it doesn't show you the exact values. Of course, that for that you would probably have to use some other application to see that or read that. I mean, you can read that in this as well, but only once you have it on your canvas, you can use this eye cursor and click on it and read all the data on the right side panel. But otherwise, this will give you most uh, category information over here, and then you can use it for various different possibilities. It says labels. You can it says no labels right now if there's no, we haven't created any. And yeah, I mean, legends if the file contains any. So most important ones I would say would be information, which says the basic information, the source, which basically just not the source from where it is downloaded or accessed, but more like what is the CRS that we are using, the symbology, the way we visualize it, the fields, and there could be one or two more, which we'll see in the next exercise that we do. So, but yeah, I mean, that's the most common method where everything will boil down to. So let's actually do an exercise, an application-based exercise on like, yeah, we know the data types, the data sets, the how to add them in QGIS, how do we visualize those, what are the things that we should look for in QGIS, but what do we really do with it, right? What can we really do with it? How far can we push our objectives, right? So I have a very simple exercise here right now, which is what we're going to analyze public transport situation in London, right? So what we're going to have is we will be having all this information about the city of London. We'll have all the water bodies, demarcation, all the bus stop points, all the railway lines shown on the map. And then what we'll do is we will also put all the points of interest. Basically, point of interest could be any important or a landmark location, sorry, which could include landmarks, railway stations, tourist spots, public buildings, parks, location of historic importance, educational buildings, etc., etc. It could also include your supermarkets and certain brand stores, anything basically, right? Anything that a person could go and access, except for a residential building, right? Because that's not a point of interest. That's like the basic building that we will require for our survival, right? So what we will really analyze is that for the amount of points of interest in any area of London, how much public transport is really available in that certain area, right? So this is not a very accurate technical objective that we are going to look at, because that would be like a much deeper layer to analyze. But as at a urban scale or at a big picture scale, what are we looking at is what areas do we really need to go deeper into, what areas are well developed already, what areas have some issues and can be developed further, or what other questions can we think of based on a simple density analysis, right? So yeah, so this pink violet image shows the density of bus stops and railway stations in each of the spots in London, or each of the areas in London. So of course it's divided into a certain grid and it shows into that grid, right? So let's see, how do we really do this kind of simple analysis, or how do we achieve this kind of objective with different kinds of data sets available. So first thing we would begin with is obviously the map of London. So I'll go to layer, I'll say add layer, I'll say add vector layer, and go to London transport folder, and we see there is a boundaries London GPKG. That's a different file format, but essentially a vector file. So I'll just say open. It says default, I'll keep default, I'll say add. I'll close this. So now, because we were zoomed into Mumbai, we don't really see the file here, but just right click and say zoom to layer. So yeah, this is all the administrative boundaries that this file contains. So okay, so what I really understand from this is it doesn't just contain just London, it contains for the whole UK mainland, it seems. So to confirm that, I'll open OpenStreetMaps. So yeah, that's whole of UK, the United Kingdom, and yeah, the file contains the whole administrative boundary for the country. But we just want to pick up for London, which is somewhere here. So now how do we find that, right? So what I'll do is I'll take identify features and I'll click somewhere closer to where I believe London is. And let's see what headers does the file have, right? So it opens all the information. Now, if we notice, it has highlighted two different boundary sets, right? One of we need to figure out which one is which, right? So now, luckily, somewhere it says it is Lambeth Council, Southwark Council. So we are not interested in that. What we are interested in is London exactly, right? So from I know, because I am in London right now, that this central boundary demarcation is London, right? So what I'm going to do is I'll just quickly scroll through where has like which one is written London. So it says again the council name. Yeah, so this one says London. But yeah, I'm not really sure if this is the one. Metropolitan Police, Lambeth Council, Vauxhall. No, this one says Newington. This is not Welbeck. Borough and Bankside. Okay, so we know that we need to put, yeah. So this is the one that we want, right? So if you see in the various information headers, there is one called name that says Greater London, right? So what I want to do is, out of all these data sets, I want to filter it out to this one particular boundary, which says Greater London. Now to do that, what I'll do is I'll go to the layer, right click, I'll say properties, as usual. Yeah. And then in the properties, I go to source. In source, at the bottom, you see there is something called query builder. So as the name suggests, basically it's in a way option to filter out something. So in the fields, if you notice, these are exactly the same headers as we saw in the information on the right panel. So from that, what we know right now is that we need to filter out based on the name, which should be Greater London, right? So I'll double click on this. So it adds over here name, right? And I want to have it as Greater London. So I'll say equal to, and then single inverted comma, and you need to type it exactly how it appeared in the information on that panel. Otherwise, it won't understand, right? So it has to go into single inverted commas, and exactly the spelling, the case sensitivity. If there's a dash in between, you have to put that as well. If there's a full stop, put it that, and exactly the same way that it appears in the information set. And then we will test it, right? So are we doing it correct? So it says the where clause written one row, which says yes, it has one value or one entry which says the name is equal to Greater London. So I'll say okay, and I'll say apply. So just say okay. Okay, it got stuck for some reason. Let's wait for that. Cool, perfect. So what it has done is it has filtered out the Greater London boundary out of all the administrative boundaries for the country that this file contains, right? It is, my system is stuck for some reason. Let's hold on to that. So this usually shouldn't happen, but I don't know why this would happen. Although, yeah, I mean, sometimes QGIS could be a little unstable. Also because it's an open source software, sometimes it does have certain issues which will get actually cleared out in the next version. But yeah, we are back with this. And now we can see that we have exactly the London boundary. So I'll turn off OpenStreetMaps. I have the London boundary. I'll remove all the other layers from here for now. So I'll just right click, I'll say remove layer. I'll select all of them together. I'll say remove. Perfect. So let's add all the other information. I'll say add vector layer. And then we have railways. So let's add railways. Now you can see it gives you all the railway lines. You can keep on zooming more and more. It will keep on giving you more details. Let's go to layer. Let's say add layer, vector layer. And I'll go to railway line POIs. Okay. Okay, I realize there is no water file in this one. So, well, that's okay. But we have POIs, which is the point of interest, which is essential for now. So I'll add that and I close. So you can see it has added dot for each of the POIs across the city. And you could check it out as well, right? So now this looks like a railway station because it has, of course, multiple railway lines, right? So if I just click on this, oh, it says F classes bench. That's interesting. Somebody has created a POI for a bench as well. It says waste basket. No, that's amazing. Fine. It says post box. Okay. And go somewhere in central London. Check this out. It says ATM convenience. It says M&S Simply Food. That's a brand of supermarket in London. So yeah, basically these are all the different kinds of POIs across the city, right? So what we're gonna do is let's add something more. So let's go to again layer, add layer. I'll say add vector layer. We didn't add the transport actually, like the bus stops and railway stores, right? So this has transport. Say okay, and say add, and let's say close. Right. So let's see where it just go. So let's just give us one thing. Why would that do? I guess I must have put a wrong file into this. Let's check out if it's a CSV file. So I'll go to delimited text layer. And then let's see what else do we have here. seems like I have chosen the wrong transport file. So okay, sorry for that. I believe this wrong file must have come into your yeah, this wrong file must have come into your folder as well. But I'm extremely sorry for this. I believe I can share another link later on, maybe for this particular transport file. But for now, what I'll get for you is the exact transport file. Okay, just give me a second. The layer. Perfect. So yeah, extremely sorry that I must have transferred you a wrong file. The names are very similar, as you can see. But yeah, this is the file that we are interested in. I'll remove this later. So these are all the bus stops and railway stations across the city. So if I just click on any of the points, it will tell me what is that point looking at, right? So let's see. Okay, sorry, it got stuck again. But yeah, it's back. Okay. Now, because it couldn't understand exactly where I'm clicking, there were like hundreds of points at the exact same location. It just selected all of them. So what I'll do, I'll just go and select a single point, and yeah, it says crossing. It says parking bicycle, which is again part of London's public transport infrastructure. This is traffic signals, fuel, mini roundabout, and all sorts of things, right? So what we are really interested in is looking at the density of these infrastructural locations across the city. So yeah, let's get started with the visualization then. We have all the information that we need on our screen right now. So what we do is, first thing is we convert this boundaries into an administrative visual. So we go to symbology, simple fill. I'll remove the fill color. I just want the boundary for now. And I'll choose white because we have a black background. Right. And I'll choose, oh, sorry. My system is acting funny. That shouldn't have been a big task. So we have to wait for this to be, yeah, perfect. So I'll just take a dash dot line because that's a more relevant way of showing an administrative boundary. And I'll say apply. Yeah, again, I'm so sorry for this, but yep, I think that looks okay for me. So I'll say okay. Next thing is, let's make these railway lines white as well, or maybe just a little more different color, which is not this highlighting. Go to right click, properties. Again, same procedure. Now, if you notice here, it's a line directly, right? So it has no fill option because the software understands that this data is only a line data or like a just a curve data, right? So it just gives me that particular option. So what I do is I probably just take white for now. Say, okay, yeah, I think the stroke width is fine. Solid line, that's okay. Yeah, we got that. And then let's get the POIs as well. So I'll just say properties, simple marker. Again, and for this one, I'll remove the stroke instead of the fill. I just want to keep the points and not the fill. So I'll reduce the size so that it's a little more visible. Yeah, that's a better way of looking at it, I believe. It's just a little more cleaner, right? Because right now we are interested with the density of POIs instead of the exact locations. So that pretty much gives us the idea of the density. Now, the real task is to get an analysis of how much public transport facility or infrastructure is available in each area. So what we'll do is we'll divide the city of London into a grid, and then we take the grid and we take like an average number of public transport points, what are available things in that area, right? So that gives us like a density of public transport infrastructure for each of the grid cells. Now to do that, first thing is we will need to create a grid. So for that, I'll go to this panel over here. I'll go to vector creation because we are going to create a grid, which is a vector element. And in that, it says create grid. So I'll double click on that. And it gives me something like this. It says grid type. So I'll select the rectangular grid. You could really select even a diamond or a hexagonal grid, like, right? Like, so hexagonal is more like a honeybee kind of a structure, sort of. But I'll take rectangular for now, and horizontal spacing, let's say 2.5 kilometers by 2.5 kilometers. So that would be 2500. So because this is in mm, usually by default. So 2500 again. And then the CRS is pseudo Mercator, which is absolutely correct. So I won't change that, and I'll just say run. It says wrong or missing parameter because we didn't tell it like how big the grid do we want. So I'll go here, I'll say calculate from layer, and I'll select boundaries London because that's the maximum extent that we want for the grid, right? So I'll say that, and I'll say run. Perfect. So it has created a grid. So it grows. Now, as you can see, the grid is exactly up to the boundary of London. So now we have the grid. Now what we need to do is we need to count the points in each of these cells, right? So what we do is, again, I go in this and I go for vector analysis. And in that, it says count points in polygon, right? So I'll double click on that and it opens this. It says polygons, which is the grid. Yes, the cells are our polygons. It asks for points. So for points, I'll select traffic points. So POIs are not the ones we want. We want the traffic or like the transport infrastructure. So I'll say traffic. And it just says if you want to add any more attributes. Nope. It says count field name. So like what it is going to do, it is going to count the number of points in each cell and create a new layer of cells based on that, right? So if you want to give a name to that layer, you can do that. But for now, I'm fine with num points. So I'll just say run. Let's wait for this to finish. So yeah, I mean, this processing time could depend on your computer processing speed and the amount of data that you're trying to process in one go. So, but yeah, that's done. So close, and I'll turn off the grid. Now it has a new layer which says count, right? So right now it's all flat, but if you just click on any of that, it says num points 39. If you click on something else, it says 0. If you go somewhere here, it says 71. So we know that it has worked somehow. So again, right click on the layer. I'll go to properties. And in properties, now we'll do the same thing we did with the house pricing thing. So in symbology, we'll go to graduated because we want to color code each of the cells, right? Depending on how many number of points do we have in that. So the first thing that we need to do is we need to select that I want classification on what logic, right? So I'm going to take equal interval, and I'll probably create 7 different classes so that we have like a good color ramp or like a good visual of graduated colors, right? So, and I'll say 7, and I'll say classify. Oh, sorry, we missed to select the value, right? I mean, based on what value should it classify? So just go to top, it says value, and in the value, select num points, because that's the number of points that we counted for, right? Let's say classify. So yeah, we can see it goes from 0 to 666, which is quite higher number actually. And yeah, you can choose a color ramp. Let me choose the ramp which is closest to the graphic I showed in my presentation. So I believe it should be this. Or is there anything else? Yeah, I think this is that. And I'll say apply. So it's okay. You can see there's like certain this, and then all of them is pink. So now this suggests that the grid is too big, right? That's why it's not able to give us a good count, or maybe our classification is probably creating certain classes which are more, like it. Certain classes have like more number than so that certain other one. So basically, idea is that there are more cells which fall into, let's say, probably 190 to 285 than this, and the difference is drastic, right? So I will rather change the classification to equal count, so that what it will do is it will count how many cells do we like. It divides based on at least some average number of cells for each of the classification. Let's say apply. So yeah, I think that gives us a better visual to understand our objective, but it still gives a very flat color in the middle. So I'll probably reduce the classifications then, and declassify, apply, say okay, that's fine. I mean, if you want, you could create even more classifications if you like. So I think that is like, this is a huge classification, right? Like 31 to 666. But yeah, I guess that's like the most numbers that are falling into. So let's say 9. Yeah, that looks like a little more better for visual. Cool. That has more now. If you notice, the pink is the lowest most and the blue is the highest, right? But it could also be that this cell falls beyond the boundary of London, right? So it's going to be 0, right? Yeah, I mean, we can clearly see it says 0 num points. We want to eliminate that from our graphic. So what we'll do is we go to right click on the layer and say properties. I'll go to source. I'll say query builder. Now we know the heading is called num points. So I'll say equal single inverted comma. Oh no, sorry, we don't want equal because we only want to keep the cells which are above 0, which means it will eliminate all the cells which are outside the boundary, right? So I'll say num points is greater than, so I'll take that symbol and I'll say 0 in single inverted commas, test it out. So it says perfect, and you can see it has eliminated all the cells which were 0, or most of them we can see are beyond the boundary of learning. Maybe the grid is too big as well for getting this density. So you could probably make a grid which is 1 kilometer by 1 kilometer. It could give you a more detailed graphic. But I guess let's go ahead with this for now. Let's change the symbology. I don't really like this pixelated form of it. So I'll go to properties, I'll go to symbology, and in the symbol, it clearly says fill instead of simple fill. I would like to take centroid fill, and that I'll go to simple marker. I'll remove the stroke again. Yeah, this is just an indicative color because it will be overridden by the graduated categories. So let's apply. So yep, perfect. What I'll do is I'll increase the size of these to probably 7 maybe. Let's see how that looks. This. So I want a little bigger. And here, go to simple marker, and then we go to 9. Probably, let's just say 15. Yeah, that looks okay to me. Now what I'll do is I'll increase the opacity of this so it has a overlapping effect. Apply. We can have a little more overlapping. Yeah, that looks better for me. So, okay. Now, if we notice, we can't really see anything of the geometry below, right? Because this is being covered by these. So I'll just pull the layer down so that we can see all this geometry. Or maybe I'll keep a point of interest below this because that's something we will merge it. So what I'll do, properties, take the point of interest, and I'll go to layer rendering over here. Now this is like usual Photoshop kind of a feature where you can set opacity, blending mode. I'll say screen, I'll say apply, say okay. Yeah. Okay, let's reduce the amount of opacity for this as well. So this to 60. Yeah, that's a little better for me. Boundaries, I'll have it above, probably thicken the boundaries. So why I'm doing this smaller detailing is because I'm going to export this image at the end, just to show you how you can print it finally. That's okay. And back again. Oh. Let's wait for this. Perfect. Okay, this got a little too thick, but it's okay for now. Cool. So now we have what we wanted on our graphic. We know the railway lines, we know the points of interest, and all these colored circles show us the density of public transport infrastructure in each of the grid cell areas. And then this shows the administrative boundary of London. So, I mean, it's pretty much obvious that the central London has more points of interest because that's the older London, the historical London city, which has later grown over the years. And then on the outskirts, it's really sparse. So even the density of public transport is sparse. But that could really be some areas where you might, find that there are points of interest. For example, this particular area over here, but it says I mean, as per the analysis, it says there's no good amount of public infrastructure for transport. So probably one can look into that area even deeper. And first thing is what they would check if the analysis came out correct based on the visual that we have created. And then if that's correct, how you could improve that, how you could hit on that a little more. And but yeah, I mean, this is like a very simple outright basic analysis that you could do for starters. And yeah, I mean, there are many more options. As you can see over here, you can you could even count like distances from one point to some other like a radius kind of a thing, that how much more you could just choose a bus stop and say how long is it to get the another bus stop from that certain point. So GIS has many more analysis features like that that you can explore out. I think I won't be taking that today, but yeah, there's much more potential to do things in here. But essentially, it's a simple process. You get the data files from authentic sources, you input the data files into the software, you process it out in the correct way, you filter it out in your correct way, you build queries to get the exact data values on your screen that you want, and then you set your visuals the way you want, and then you do your analysis and then set the visuals for that as well, right? So to end this, what we're going to do is we'll export this. So I'll just go to project export. I'll say export map to image, and it asks me the extent of the map. So I'll just say map canvas extent, which is by default anyway. It asks me for a scale, like right now it's taking the scale that it's zoomed in on my screen, but you could really choose any scale. I'll keep the scale for now. You can choose the resolution, your output resolution, and just say save. It will ask where do you want to save. I'll go to desktop and I'll just something. Let's just save. So yeah, it's processing it, it saved it. So yeah, the image is saved as per your resolution and whatever you have. Now you can use this. Now, if you want this with a legend as well, what you can do is you can go to project, you can go to new print layout, you could just title it something. Then it creates like a sheet for you. And then on this, you can go to add item, you can go add map. So you just create a map on this. So it's basically just the screen that you have at the back on your paper size. So you could really just go to all these usual options and then set your paper sizes and everything. So if you go to layout here, it says reference map. Number one, it says grid spacing. If you want to keep the export settings, you want to do the margins you want to leave, right? And then I go to add item, I'll go and I'll say add legend. So I'll just add the legend over here. Right, so now it has put all the legends for all the available layers in the file, right? We can see from here. So you could really go to this, and then you can turn off the legends you want and things like that. So you can do all the font and text formatting. You can do the columns. You can do sizing, rotation, everything, even the symbol and everything. You can just format the whole thing out from here. And yeah, you could select each of the legends that you want, and you can change certain things from here. So this is like your formatting space to put this, right? But I think for now, I just leave it here, and one can explore this at their own time. There's like a lot of simple things that you can do using this from here. So, is there anything to show? Yeah, no. So these are all just formatting tools from here, and then you can just save this, and then you can just print this as a PDF, export as PDF, export as image, and you would have all your maps with all the legends and things like that ready, right? So I believe that's it for today for the GIS thing, right? And then you can just save the file as GIS format thing. But I just want to show one last thing before I leave for this, which is the little exploration that I did with geospatial data visualization and urban cartography beyond this particular software. So I'm sure all of you are curious on what is this cover page, right? Because this has been used in the Instagram post as well, and how what is it exactly? How do I do that? Right. So it's not the contour way that I showed you on QGIS, but it was done in Rhino and Grasshopper. So the objective for that was to analyze certain tweets about a certain area, and the tweets contained on how people had certain sensory experiences in that particular area, right? So we searched out tweets based on certain hashtags which were related to sensory experiences. So these were the hashtags that I showed you in this. So all these words were used as hashtag finders for all the tweets in certain area. And then yeah, we were to identify the hotspots for where are people experiencing better, where are people experiencing not so great in that so particular area. So these were like tweets from 1 week of time in a certain area, and they were geolocated because how do we geolocate them was the tweet when you share any post on any social media, we generally tend to put a location tag on them, right? So these tags were probably based on certain restaurants or certain buildings or things that people had tagged, right? So uh, yeah, they were these points that we had on the map, and then we just based on what the tweets were about on those points, we gave them certain weightage from 0 to 4 based on how good they were or how bad people felt in or people were talking about in those certain tweets. And then we put it on a Rhino surface, take it into Grasshopper, divide the surface, and then what we do is we pull those surface points based on the proximity to our tweet points and the weightages, right? So idea is if the tweet point has let's say weightage of 4, the surface point will go up, and that much amount of up based on that weightage, right? So if the weightage is 0, the points will go down, right? So based on that, we pull and push the points up and down, and then we recreate the surface based on those surface points, and then of course contour of that, so sorry, slice of that surface. So that gives us a contour, and that's in the 2D, contours in 2D. And then we do the color gradation based on the contour levels. So bottommost is blue and the topmost is orange. And then with some graphical improvements in Adobe Illustrator, we place it on the map and put like the hashtags we had for those tweet points that you can read probably in this. So these points are all the network of tweets that we had, and that's like the 3D graphical improvement for that particular contour surface. And yeah, these were like different diagrams for different 5 senses that we did, all the 3Ds for that. And there was another image in the Instagram post, which was so the objective in that was to understand the smell perception in certain urban area of London. Now, understanding smell is really complicated because we don't really have a digital technology which directly connects us to smell. For example, visual and audio is very easy with digital technology, but so far the development with understanding smell and converting it into a digital realm has been difficult. Not that it hasn't been done, but it's just not that accessible right now, right? So we found out our own, we just tried out our own way of doing that. And we created a setup of 9 micro sensors, which wherein each sensor detects a different gas, right? So every smell or every air component is made up of different gaseous components, right? So, I mean, obviously there is nitrogen, carbon, oxygen, hydrogen, things like that that we know, but those are like still some very basic elements, but there are things beyond that. It said there are certain compounds like sulfur or things like that. So to give you a simple example, if you cut an onion, it gives out compounds which contain sulfur, and that sulfur makes you cry, right? So that logic we applied, of course, with a little more research about on choosing on which gas sensors do we choose. And then this is like we classify those different sensors with each of the gases and gaseous components it can identify based on certain smell classifications. And then we go and we gather data with those sensors on site. Now, if we are gathering data with that sensor, we are getting a CSV file, which has certain gas numbers on each interval of certain time period. For example, we had 10 seconds interval. So every 10 seconds, it shows what amount of gas is present at that point. So we can, of course, create a linear chart of all those 9 gas sensors, right? Like something like this. It's an actual chart of 1 minute of data from that. But the problem is like how do we identify what location was it? So we just converted a linear chart into a circular chart, which sort of is still a linear chart for the data, but it also gives us a geolocation in the center of it, right? So that we named it as a smell rose diagram for obvious reasons you can understand from the name. And then with some graphical improvements, this is how it looks. So it's like a data reading of 1 minute. So you can see the timing on the periphery and all the 9 gas sensors. So the chart indicates the excitement in the sensor when a gaseous component hits that particular sensor, right? So a combination of those excitements tells us that, oh, there was certain gas or certain smell present in that spot. And we, of course, do our physical noting of what smells we were having, and we collate that with these timings and then form the smell dose diagrams. So these were like various different smell dose diagrams. And we took a point cloud model of the area. So that's again a very easy process using Autodesk Recap. And then we place these Smelrose diagrams on the whole street and at the points that we were really taking the readings on. So yeah, this is like a very custom data visualization, geospatial data with a very custom made data set that we use with Rhino and Grasshopper. And trust me, like to do this in Grasshopper is a very simple logical and mathematical task. You just need to know some basics of it, and anybody can try it out. But yeah, I mean, this could be a completely different tutorial. But yeah, it was a combination of many different softwares, right? So probably that's why I didn't really take this up in this session. But QGIS is one of the most powerful tools for data visualization in the field right now. But if you have a hang of some other software where you feel you can explore graphics, please feel free to go on and do that. And yeah, I think that's the end of my presentation. And I guess I can cover the questions if there are any.
Yeah, I think there were a few questions, but yeah, let me first of all just say thank you to you for such a comprehensive tutorial. It was very interesting to especially see the applications that you showed and even some of your personal works. I think we have one question from one of the participants, and then I'll begin with some of the questions that I have for you.
Sure.
So, yeah. Do you want to ask your question? Okay, I'll just put forward the question. I think one of the participants was not able to find out certain maps that you showed, and this was in the beginning. So I think there were OpenStreetMap. So do you want to put links for the students maybe in the chat? Yeah.
Yeah, sure. So for India specifically, yeah, I mean, as I said, OpenStreetMaps is like a community-based platform where people from various areas come out and put maps for their own localities or for the localities that they are interested in. So probably OpenStreetMaps might not have enough data for India because there might not be enough people putting out maps for that. But what you can do is there are some official platforms by ISRO, which I would believe to be the most authentic platform. There's also Map My India, but I haven't really worked out with how accessible the information is from there. But ISRO I can definitely recommend. So when you open that ISRO link, you come down to this, and then you can have a 2D view of that, or you can directly just go to Open Data Archive that they have here. And then this takes you to this map. So basically, in here, you can select the satellite that you would like to use, for example, or let's say I would just say take Cartoset and say select products. I mean, for us, it's going to be pretty much the same. For very expert and professionals who would know the technicalities of these different kinds of data sets, they could probably dig deep into it. And then you could be using tiles. That's like, for me, that's like the easiest way to select my area. So how tiles works is, yeah, it breaks the whole map into certain grids, and then you just select those grids, whichever you want. And then you say next, and then it shows the amount of data that you can access from here. So yeah, it says registered user. So you will have to register to download, obviously in the first. So it says data type is elevation. So again, this is going to the satellite image that I showed, but it shows locality information. And then, yeah, they have this platform as well, which is exactly the mapping platform. So I believe this is like the most authentic place where you can access things from. So you can access it in different details as well. You can have footprint for 2.5 meters of grid, 5 meters of grid, etc. But yeah, I think this is the best website for India. There's a Map My India as well.
I think much like what we have the problem in India to extract the data, there are definitely a lot of regions across the globe which are not that mapped as much as some of the metropolis around the globe are mapped thoroughly. For instance, Barcelona, New York, London are quite thoroughly mapped with the QGIS, OpenStreet softwares as well. But I think you picked up on a very interesting point of using social media data in one of your examples that you were showing. So could you throw some light a little bit more on how can one use the social media data from Facebook, Twitter, APIs? What kind of workflow do you use in that case?
Right. So I think before going to that, I'll just show another interesting thing for India where you can access data. For like just like how these big cities, London, New York, Barcelona, etc., have their own data stores, platforms like websites, which are put out by government, private organizations, etc. India has also now created one, which is it's called data.gov.in, and it's still not pretty much there like the cities that we are talking about, but we are trying to be there, right? So there's a lot of data already available here, which is being created in today's time, but for some of the data which is still probably physical, it might take some more time to get it here. And you can access some APIs of government organizations as well, or you could even request data sets from the government. You could access like they are creating data sets for state-wise zones as well. So you can see all these links running at the bottom over here. So yeah, we are sort of coming on to that. Yeah, and then moving to the question like social media data. So there's like a system of APIs which you can use. For example, if I just go to, let's say, Twitter API. So every as far as I know, like as far as my research has reached, these websites have a separate section for APIs and accessing the publicly available data. So the idea is that that all the posts and all the information that you can see about any person on a social media is limited to one screen, one profile on our phones, right? But it's still public, which means it is openly accessible, right? So you could really extract that in a bulk as well for all the public information that's available. But of course, you could have, you would need to create certain categories, otherwise it's a huge amount of data. So you could just search for these, let's say, Twitter API, and it will give you a whole website where it explains on how to access the data, what kinds of data will they give, what kind of permissions would you require from them, what all things can you do. They also give you like instructions on how to get started, what is the Twitter API, how to get access, how to go about this. And there's also an application called Postman for Twitter API. I think I've used it for Twitter right so far. I'm not sure if it can be used for others, but yeah, that's one another easy application what you can use for Twitter extraction. But Instagram has actually increased the restrictions on access to API right now, so it's really difficult to get that. But these kind of APIs are available for all sorts of platforms. So for example, you could even get it for Zomato. right? So you could get all the restaurant ratings and things like that. Whatever amount of data that they are putting. It could also be Ola, Uber can also be accessed the same way. Also, there are certain forums of data analysts. So we are not really data analysts in expertise, but there are certain platforms like Kappa Store, not sorry, Kappa Store, like that's the wrong one. So it's called Kappa or something. I forgot the name, I guess. But yeah, there are like forums like that. I think I have that name. Where the analysts who have extracted certain amount of data, they would upload there as well, and then you can extract it from those experts.
Okay. I think I was just going to come to Sensible City Lab of MIT as well, and I see that as part of the links. But maybe I'll just what I want to ask is, I think at some point in your tutorial you were also looking at a data set which was almost like 50,000 points or something. So I'm wondering that what are the current kind of questions, especially regarding sorting of data, and in the context that now we have a lot of data that can be sorted through machine learning. So what would be the best possible institutional research or papers or something, reference points that you could maybe talk about?
So I think one most commonly used method is the it's called K sorting or something.
K-means clustering.
Yeah, K-means sorting, right? So that's like one of the most commonly used methods for ML processes for sorting your data sets, wherein you could, yeah, I mean, it literally like automatically tries and collates all the data sets that you just give it to. Like you don't really even have to take out value filters, right? You just have tons of data sets and you just feed it in, and it just starts sorting what all are more relevant data sets that you could look in, what all data sets you could really eliminate out and not even put your time into looking into that and try to collate it. So that's one. But beyond that, I believe for our relevance as architectural designers or urban designers, I think could be, I'm forgetting some names right now, but this so he was my course director at the Bartlett, and he is like one of the forerunners into using machine learning and AI methods in urban design, especially. I think he has even written a book called Crypto Architecture or something. Sorry, I'm forgetting something in that.
Yeah.
Oh, Botazi, not Botazi, sorry. This guy here. Yeah, notes on machine learning and design. So yeah, Roberto Botazi. So he has been doing a really good amount of research into how we can use machine learning for our relevance, especially. And then there's another interesting guy called Lev Manovich, again, connecting it back to social media. So he uses Instagram data for urban analysis, and he has really interesting explorations completely based on Instagram data. So one could look at him as well. He also has like a what do you say, like a interactive platform where he has put out his analysis of the New York Broadway, like one stretch of New York Broadway, completely analyzed with Instagram information, collated with more demographic informations as well. So there are many papers that he has put out as well. So one could look at that. And there's, of course, Sensible City. So Carnorati is again one of the most forerunners of this field. Definitely, that would be a must look at name. But yeah, I think that's those are some of the names I can remember.
Okay. Okay. Thank you so much. Before we leave, I'm just going to quickly announce for the next session for our audience to be updated on what's coming forward this month. On 9th of April, at the same time on Saturday at 10 a.m. EST, 4 p.m. CET, we have our next in the series of insider talks with the ETH Zurich. Earlier sessions were MIT and ICD Stuttgart. All our language sessions, including today's tutorial and other talks on AI, neuroscience, and architecture, and other philosophy sessions are all placed at our YouTube channel, Digital Futures. If you're interested in taking any of the summer workshops, Dhruval, this is an invite for you as well. And or hosting any of the language sessions, please reach out to us at info@digitalfutures. We are now at lookout for new team members. And thank you so much. This was a really good session, and I think there's a lot to look forward to in the field of urban cartography. Cartography is no more now left to just mapping as a process, but it's to explore these opportunities that we can explore with the data sets that we have. So Dhruval, looking forward to maybe a second session with you.
Sure, definitely. I mean, next probably I can take on to the Grasshopper custom visuals that I tried. Yeah, but yeah, it was an absolute pleasure to be here and collaborating with Digital Futures. Always look forward to all the content that you guys put out.
Yeah. Okay. Thank you guys. Thank you for all those are connected over here on Zoom and on YouTube. Thank you so much.
Thank you so much.
Yeah. Bye.